Today's lesson's over rule number 2 of learning target 1. Here, the rule is going to be about distributing to the bases. So when you have an exponent on the outside, you're actually multiplying those exponents and the exponents on the numbers or on the variables that you're given. So like for the first example here, I have a 4 on the outside. And so the 4 is actually supposed to be multiplied to the exponents of the 3 and the x because they're both individual bases. Now remember, when they're not written there, it means that they're an exponent of 1. So that 4 gets multiplied to those 1s. So I'd have 3 to the 1 times 4 power and x to the 1 times 4 power. And that would get me 3 to the 4th times x to the 4th. Now, remembering from last video, when I know a base, which is the actual number, 3 to the 4th is actually 81 in this case. So I'm going to write that in. So my final answer for that one would be 81 times x to the 4th. Okay, same thing here. Now, even though there's something in the denominator, it still gets this exponent. So the 3 gets multiplied to both the exponents on the top and to 5's exponent on the bottom. So then I write that in. Since they're all multiplied by 1, it's just 2 to the 3rd times x cubed divided by 5 to the 3rd. Now I know what 2 and 5 are for bases because they're actual numbers. So 2 cubed is 8, and then 5 cubed is 125. So my final answer is 8 times x cubed divided by 125. Okay. Now sometimes they do have actual exponents there, and so you don't have to write anything in. So you just multiply it to that. So here the 2 gets multiplied to the 5 exponent for the base of 2. So 5 times 2 gets me 10. And because I know the number of 2 to the 10th in the calculator is going to be 1,024. Okay. Sometimes you have a mix of ones you know and ones you don't know. Here 5 gets to go to A's exponent, which is 3, negative 2's exponent, which is 1, and B's exponent of 4. So then I multiply all those out. So 1 times 5 gets me 5, 3 times 5 gets me 15, and 4 times 5 gets me 20. Now here, one thing to remember for the negative 2 to the 5th, it's both like the negative and the actual number. So negative 2 is being multiplied 5 times to itself to get us negative 32. That's a key thing to remember when it's a even exponent, just to keep in mind because it'll make that number positive. All right, so for number 1, let's try some of these. So I multiply the 2 to all those exponents for 4h and k. I know what 4 is, so 4 squared gets me 16. So my final answer is 16h squared k squared. Okay, I do the same thing for number 2. I'll multiply that 2 to the 4 and to the 3 in the exponent area. So that'll get me m to the 8th divided by n to the 6th. Okay, here the 3 gets multiplied to all those exponents. So I'll get negative 3 all to the 3rd power, n cubed and r cubed. And because I know what negative 3 is, negative 3 to the 3rd power is actually negative 27. So I can simplify that number further. Okay, on number 4, same idea. I got the 4, goes to all those. The 5 has an exponent of 1, so it gets that 4 as well. So 5 to the 4th times x to the 24th and y to the 28th, which is 7 times 4. Remember, I know 5 to the 4th here, so I can actually plug that in and get 625. And that would be my final answer. Okay, now we're going to actually kind of combine the two rules that we talked about in this next video, or in this next portion. So here, usually because of order of operations, exponents go before multiplication. So you're going to probably use rule number 2 first a lot, and then you'll have to come around and use rule number 1 because you're going to be multiplying what's left if there's any like bases. So rule number 2, I take that 2 to everything. I simplify that fraction. Now I notice that I have a b in the fraction and a b out front. b to the 6 is like saying b to the 6 over 1, so it gets multiplied to the top, so that's fine. So I actually get to add those exponents because I'm multiplying. So 2 plus 6 gets me 8, and that'll be my final answer there. Okay. Number 2, I see that there's a 4 here that's on the outside of the second parentheses. Now notice it's only going to the 3x, it is not going to the negative 2x, so I'm going to leave the negative 2x alone. And so the 4 only goes to the 3 base and to the x base. And so then that gets me negative 2x times 81x to the 4th. And now I get to use rule number 1 because I see a negative 2 times 81 and an x and another x in my two bases or in my two parentheses. So I'm going to put those like bases together, multiply. I'm going to add those exponents. So that gets me negative 162 times x to the 5th. Okay. Now sometimes you can do both rules at the same time, especially when you have a fraction and there's one on top and one on bottom. So on the top I have rule number 1, so I'm going to add those exponents. On the bottom I have rule number 2, so I'm going to multiply the 7 to the 2. Okay? And you can do these things at the same time, that's okay. All right, and then number 4, it looks like I have two parentheses that have rule number 2 going to it. So I need to deal with both separately. So the 3 goes to the 5 and the p. So I get 5 cubed times p cubed. And then I also have a 5 going to the negative 2 and the p cubed. So I get negative 2 to the 5th times p to the 15th. And now I have a bunch of stuff that I can use rule number 1 for. So I'm going to put the 5 cubed, which is 125, and negative 2 to the 5th is negative 32 in parentheses together. That gets me negative 4,000. I'm going to add those exponents for the p. So I get negative 4,000 times p to the 18th. Okay? Have fun.